All right, welcome to the Explainer. Today, we are cracking the code on a real power couple in the world of big data, Apache Spark and Databricks. We're going to look at the engine, and then we're going to look at the supercar built around it. Okay, so think about this. Every single day, we generate an absolutely insane amount of data. It's way, way too big for any single computer to even look at. So how in the world do companies like Netflix or Spotify or your bank process all of this information to make decisions and, run their business? Well, you need a totally different way of thinking. And that solution, it all starts with this revolutionary piece of technology that was built from the ground up for one thing: handling massive data sets with incredible speed. Okay, let's get into it. We're going to start with the first key component here. We are talking about Apache Spark. This is the powerful open source engine that's really at the heart of most modern large-scale data processing today. The best way to think of Spark is as this super fast, do-anything engine. Its whole job is to take a giant, complex task, smash it into 1,000 smaller pieces, and then run all of those pieces across a whole cluster of computers at the exact same time. That parallel processing, that's the key to its incredible speed. And this slide, this is where you really see Spark's secret sauce. See, older systems like Hadoop MapReduce were constantly reading and writing data to a slow physical hard drive. Spark, on the other hand, does almost all of its work right in memory, in RAM, which is just orders of magnitude faster. It's really the difference between digging through a filing cabinet versus having the document sitting right on your desk. And here's how it orchestrates all that work. You've got your main driver program, which is kind of like the head chef in a kitchen. It takes your recipe, your code, and figures out all the little steps. Then, the cluster manager acts like the expediter, handing out those tasks to a whole bunch of line cooks, which are the executor computers. Each executor just works on its own little piece of the data, and then everything gets put back together at the end. And here is the really crucial part. This whole system is built for the real world because, let's be honest, in the real world, things break. If one of those computers in the cluster just dies in the middle of a job, Spark doesn't crash. It just notices. And it reassigns that one specific task to another healthy computer. Your job just keeps on chugging along, which is absolutely essential when these things can run for hours. So we've got this amazing, powerful engine. But an engine's pretty useless if you don't have a steering wheel, right? How do you actually tell Spark what you want it to do with all that data? Well, that is where PySpark comes into the picture. It lets you use Python, one of the most popular programming languages on the planet, to give commands to the Spark engine. And the main way you do that is with something called a data frame. You can just think of it like a giant spreadsheet, a table with columns and rows that's spread out across hundreds of computers at once. And with PySpark, you use these really simple, intuitive commands to shape your data. So for example, a map operation is a one-to-one change. For every item you put in, you get one item out, like changing a list of names to all uppercase. But something like flat map, that's a one-to-many deal. You can give it one sentence, and it can break it apart into a whole list of individual words, which is, super useful for analyzing text. And just like you would in a regular old database, PySpark makes it really easy to combine different data sets. You can do all kinds of joins to stitch tables together. Like connecting a table of your customers with a table of all the recent orders to get that full, complete picture of what's going on. Okay, so an engine and a toolkit. That's awesome, right? But setting all that up, managing all the computers, tuning it, keeping that whole workshop running, that is a massive job all by itself. And this is where our story gets a major upgrade. Seriously, think about that for a second. The raw power of that Spark engine is just undeniable. But what happens when you take that engine and you drop it into a perfectly engineered, highly optimized, and super user-friendly chassis? Well, that's the leap we take when we go from just using open source Spark to using the Databricks platform.
Now, here's a really important distinction. Databricks isn't a replacement for Spark. It's a complete, high-performance vehicle that is built around the Spark engine. You can absolutely build everything yourself with the open source parts, but Databricks gives you a platform that just handles all the hard stuff for you. The setup, the tuning, the management, it's all taken care of.
It wraps Spark up in this whole suite of tools that just solves the biggest day-to-day headaches data teams have. Things like collaborative notebooks so everyone can work together, or automatic job scheduling. And maybe the most important one is auto-scaling. That means it automatically adds or removes computers as your job needs them, so you only pay for the exact power you're using at any given moment. That's huge.
So, we're in the supercar now. What's the killer feature? What's the secret weapon under the hood that really makes this thing a game changer?
Well, one of the absolute crown jewels of Databricks is something called Delta Lake. It was built to solve a massive, long-standing problem with what we call data lakes, which are really just these giant repositories of raw data files. The challenge has always been keeping that raw data reliable and consistent, and that is exactly what Delta Lake is for.
And it does this by bringing ACID transactions, which is a bit of a fancy term, but it's basically a set of guarantees that used to only exist in old school traditional databases, and applying them to these flexible data lakes. The bottom line? No more corrupted data because a job failed halfway through. Atomicity means a change either completes 100% or it doesn't happen at all, which keeps your data pristine. But the reliability that all this gives you, well, it unlocks something else. Something that sounds like science fiction, but I promise you it is very, very real. It is literally like having a universal undo button, a Control-Z for your entire data warehouse. And it's actually called time travel. Because Delta Lake keeps a perfect log of every single change that ever happens, you can instantly look at or even restore your tables to the way they looked at any specific point in time. Someone ran a bad script and messed things up? No sweat, just rewind. You need to reproduce a report from last month exactly as it was then? You can do that. It is an absolute game changer for data reliability. So, there you have it. We went from a raw engine like Spark to a fully equipped supercar like Databricks, complete with a time machine. We've kind of revolutionized what's possible with these massive data sets. But the flood of data isn't stopping. It's only getting bigger and faster, which really just leaves one big question. What comes next? What comes after the supercar?